Okay, so what if the key to understanding something like algebra wasn't hidden in a textbook, but in stories that are thousands of years old? Well, today, we're diving into this really fascinating lesson plan that does exactly that. It connects ancient narratives to modern math. Let's see how they pull it off.
And really, this is the big question, right? Can these ancient stories genuinely provide a framework for something as abstract as algebra? I mean, on the surface, it sounds a little out there, but let's actually dig in and see. So first up, we're going to deconstruct the lesson plan itself. Now, this thing was designed for sixth graders, and its whole mission is to bridge these two worlds that, couldn't seem farther apart.
And here it is, the core idea. This isn't just about adding some historical flavor, it's a genuine teaching strategy. The whole point is to use the drama and the action of these familiar stories to make tricky ideas like variables and relationships suddenly feel real and, well, tangible.
But you can't just jump into the stories. Before any of that, the lesson has to lay down the law, mathematically speaking. It has to build a solid foundation.
Everything, and I mean everything in this lesson starts with this one big idea, an algebraic relationship. The easiest way to think about it is just cause and effect. One thing changes, and it forces another thing to change right along with it. It's a simple concept, but it's incredibly powerful.
Now, in any of these cause and effect situations, you've got two main players. First up is the independent quantity. This is your cause. It's the thing that gets the ball rolling, the value that you start with. And of course, for every cause, there's an effect. That's your dependent quantity. Its value changes because the independent one did. So just remember, independent is the cause, dependent is the effect. Okay, now that we've got that down, we can finally get to the stories. And this is where it gets really creative. This is the moment where the lesson takes these rich narratives, full of emotion and action, and translates them into the cold, hard logic of data tables and graphs.
So the first example is Moses leading the Israelites out of Egypt. In this story, the number of days is the independent cause. I mean, time is going to pass no matter what, right? And the miles they travel, that's the dependent effect. It's the direct result of each day's journey.
And as soon as you plot this on a chart, the relationship just jumps out at you. It becomes so obvious. You don't even really need the numbers to see the pattern, do you? It's just a steady, predictable climb, a perfect picture of a linear relationship. And then the lesson ties it all together with a simple sentence. It translates that mathematical pattern right back into the language of the story, making that connection between the graph and the journey crystal clear.
Okay, the next example shows us a completely different kind of relationship, this time using the story of Gideon's army. Once again, time, the number of days, is our independent variable. But this time, as the days go by, the dependent variable, the size of the army, just plummets.
And whoa, when you see it on the graph, the change is just so dramatic. You see this huge army shrink down to almost nothing. The visual impact here is way more powerful than just reading the numbers in a table. You can actually feel that drop.
Now, this interpretation adds a really crucial layer. It gives us the narrative reason why the numbers changed. It links the mathematical effect back to the cause in the story, which in this case was a series of divine tests for the army.
So this final example gets even more abstract. I mean, how on earth do you put a number on something like faith? Well, the lesson gives it a shot. Here, the independent quantity is the height of the waves, an external threat, and the dependent quantity is Peter's level of faith, a totally internal state.
The graph immediately shows us what's called an inverse relationship. It's super clear. As the wave height goes up, Peter's faith level goes down. The bigger the storm, the smaller the faith. Again, a picture makes a really complex idea totally simple to grasp.
And this final summary just brings it all home, putting the relationship into plain English. It perfectly connects that external, independent challenge with the internal, dependent response.
So, after walking through all these examples, the lesson does something really smart. It turns the tables. Now it's the students' turn to put on their analyst hats. The homework gives them a really clear process. They're given the story of Joseph and asked to do the exact same thing they just learned. First, analyze the story to find quantities that change. Then, create a data table. After that, plot it on a graph. And finally, explain the relationship they discovered.
But then it goes one step deeper. The lesson asks the students to find a turning point. And this is brilliant because it pushes them beyond just plotting data and forces them to analyze the narrative itself.
They have to think like a storyteller and a mathematician at the exact same time to find that one key event that caused the biggest effect.
So, at the end of the day, what's the big takeaway here? What's the real point of mixing storytelling with mathematics?
Interestingly enough, the lesson plan we're looking at wraps up with this verse. It seems to be there as a final piece of encouragement, connecting the whole theme of overcoming challenges, both in the stories and, in the math problems, to a bigger motivational message.
And that kind of leaves us with one last thing to think about. This lesson used biblical stories to explain algebra, but the principle behind it could apply to anything. So the question is, what complex idea in your world could you finally understand if you just found the right story to unlock it?